Hi, this is Mr. Merrim. In this video we're going to talk about the differences between instantaneous velocity, speed at a time, average velocity, and average speed. So we'll be looking at this position versus time graph, and we want to keep in mind these three formulas. These should be pretty intuitive to you. So what is a velocity at 11 seconds? So if it's asking what the velocity is at 11 seconds, it's asking for the instantaneous velocity. So what it's asking for is the slope of the line at 11 seconds. So if we look here at 11 seconds, it's asking for the slope of this segment of the graph. So to find that, we can look at the rise over run of this segment of the graph. And if your first intuition is to count the grid, remember that's a mistake, because we have to look at the scaling of this graph. So if I want to think about the rise over run, I need to think about, okay, this goes down 5, 10, 15, 20 meters. And it goes over, again we have to look at the scaling, so the scaling here is each block is 2 seconds, so this goes over 2 seconds. So the velocity at 11 seconds we found from the slope of the line, so it's just negative 20 meters over 2 seconds, giving us 10 meters per second, negative 10 meters per second. So the speed at 11 seconds is just the magnitude of the instantaneous velocity at 11 seconds, so that's going to be just 10 meters per second, no direction. The average velocity, again we can look over here, from 0 to 20 seconds. So the key to this is finding the displacement. So the displacement is our current position minus our initial position. So our current position at 20 seconds is 20 meters. I found that by going to 20 seconds, looking here, and then realizing that's 20 meters on this position axis. Our initial position at 0 seconds, so 0 seconds is 15 meters. So from 0 to 20 seconds, I've displaced positive 5 meters. And you can also find that by taking 20 minus 15. So our displacement during that time interval is positive 5 meters, and displacement's a vector. And then to find the average velocity, it's just a matter of taking that displacement and dividing by that length of the time interval. So 5 meters divided by 20 seconds be 1/4, or 0.25 meters per second for our average velocity. Like I said, this last part where we talk about average speed is the most difficult for people, because what this has us do is we have to think about the problem a little more carefully instead of just thinking about some formulas. So the average speed is the distance over the time interval. So to find the distance, we want to think about this problem in terms of these different motions. Okay, so in this portion of the graph, this is from 0 to 2 seconds, we started at 15 and we go to negative 10. To do so, we had to travel 25 meters. In this portion of the graph, we started at negative 10 and we go to 5. So that's us traveling 15 meters. In this portion of the graph, we're at 5, we go to 5. That's because we're not moving. We have a 0 velocity, so we don't travel any distance. In this portion of the graph, we start at 5 meters. We end at negative 15 meters. That's 20 meters of travel. In this final portion of the graph, we start out at negative 15 and we go to 20. So that would be 35 meters. And what we're doing is calculating all the distances from all those different segments of motion. So this is going to be, that would be 40 plus 60 plus 30, so we have 95 meters. So to find the average speed, so try to get used to this notation, we'll have to do 95 meters divided by 20 seconds. And we get 4.75 meters per second. So it shouldn't be surprising to you that the average velocity and average speed are very different, because the average velocity doesn't take into account all this forward-back motion. It just looks at the initial and final position, where the average speed does account for that backwards and forwards motion. Okay. All right. So hopefully that's helpful to you, and if you have any questions, just send me an email.